Hello, in this video I'm going to solve the following problem for you, which is a problem on the topic of number systems in number theory. Let A be a natural number if capital A, which is this 4-digit number A to the base A plus 1, then what is A squared in the base A plus 1? That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, the answer that you will get is as follows. It becomes an 8-digit number, A minus 1, 0, 0, 0, 1 to the base A plus 1. For more problems of this type, the interested audience can refer to the following playlists. The link to the PDF file that you can see on the display right now is in the description below this video. Okay, in order to solve this problem, and because I need to know A squared, so the best thing that I can do is to go to base 10, because if I go to base 10, I can use all my knowledge that I have in the standard base 10 and do the calculations, and of course I will switch back to the base A plus 1 at the very end. Okay, so what should I do? The first thing to do is just go from base A plus 1 to base 10, and there is a standard way to do it, yes? So A becomes equal to the units digit multiplied by this base to the power of 0, which is just the units digit, plus the second digit, or the 10th digit, is A times A plus 1 to power 1. The next digit is again A times A plus 1 to the base 2, and the next digit is A times A plus 1 to the power of 3. Why is that? Because, for example, if you have A1, A2, A3, A4 to any base B, you know that if you want to go to base 10, you write A4B to power 0 plus A3B to power 1 plus A2B to power 2 plus finally A1B to power 3. That is the expansion of this 4-digit number in base 10 if you want to write it in base B, if you want to write it in base 10. Okay, one thing that immediately comes to mind is factoring A out. And then it becomes 1 plus A plus 1 plus A plus 1 squared plus A plus 1 cubed. Okay, if I ask you what is this, you will tell me this is the same number A but written in base 10. And I know all the rules how it works in base 10. I want to square it. So it means that I have to square it and then write it in a way that it becomes as a sum of consecutive powers of A plus 1, so that I can interpret A squared in the base A plus 1. But of course, if I want to raise it to power 2 like this, it is very tedious. So what I will do, I realize that these are the terms of a geometric progression whose first term is 1 and the common ratio is A plus 1. So let's remind you of a geometric progression. Geometric progression is a sequence of numbers, say t sub 1, t sub 2, t sub 3, etc., so that every term is obtained from the previous term by being multiplied by a constant number. That constant number is usually denoted by R, and it is called the common ratio. Okay? So why this is here? Because you see that every time that I progress here, this term is obtained by the previous term by being multiplied by A plus 1. But again, this term is obtained from the previous term by being multiplied by the same factor A plus 1. This one is obtained from the previous one by being multiplied by the same factor A plus 1. So they are really forming a geometric progression whose first term is 1 and the common ratio is A plus 1. And I want to sum up the first 4 terms. There is a formula for Sn, the sum of the first n terms of a geometric progression. I don't want to prove it. You can refer to other books to see the proof. This is a very standard one. The formula is this. So the formula tells you that if you are interested in the sum of the first n terms, take T1, multiply it by the common ratio to the number of terms you are interested in, minus 1 divided by r minus 1. So here, in this problem, this becomes S3. So I copy and paste this A here, but then I know what to do. So I have a fraction here. The denominator is r minus 1, but r in my problem is a plus 1. A plus 1, so what happens? This becomes a plus 1 minus 1. And the numerator is T1, which is 1, and then you have a plus 1 to the nth, and here is 4 minus 1. But now something interesting happens. This 1 and that 1 are gone. This a, which is left in the denominator, will be cancelled by that one, and 1, we don't need to write it. So it becomes very simple. So it becomes a plus 1 to the power of 4 minus 1. So this is my a. A is a plus 1 to the 4th minus 1 if I write that a in base 10. But now I am interested in calculating a squared, of course, so this becomes a plus 1 to the 4th minus 1 to the power of 2, which becomes the first one squared, 2 times the first one times the second one, and the second one squared. Now I have to write it back in the powers of a plus 1. Of course, this is still in powers of a plus 1, but I am unfortunate a little bit because this one turns out to be negative. To explain it better, so let us assume that this were not positive. It were not negative and it was positive. For example, let us say that we were lucky and instead of getting this expression, I just got this expression. Then, more or less, I am done. Why? Because I can write it as 1, a plus 1 to the 8th, and then a plus 1 to the 7 does not appear. I bring it in with coefficient 0. A plus 1 to 6 does not appear. I bring it in with coefficient 0. The same for a plus 1 to power 5. A plus 1 to power 4 appears with coefficient 2, the other ones with coefficient 0, yes? And finally 1. Okay, if that was the case, then I could write this number in base a plus 1 by writing these digits, yes? This one, this one, this one. These are my digits then. Okay, so then it would be number 1, 0, 0, 0, 2, 0, 0, 0, 1 to the base a plus 1, then I was done. But unfortunately I am not that fortunate, so this is not going to work. I have to find a different way. Okay, so let me clean this wrong one and then try to find a way. Okay, the other one that I want to do, I will start to here, and little by little I will decompose this a plus 1 to power 8 so that I can borrow enough coefficient when I reach here makes this negative to positive. How I want to do it, I have to be patient and do it term by term, I mean step by step. So a plus 1 to the power of 8, I can write it as a plus 1 times a plus 1 to the power of 6. But then I multiply a here and 1 here. So this becomes a, sorry, this was not 7, this is not 6, it should be 7. That was my bad, sorry. Because a plus 1 to the power of 8 is a plus 1 times a plus 1 to power 7. I will take this a and multiply it by the whole combination, and then I will take 1 and multiply it by the whole combination. So this becomes equal to a times a plus 1 to the power of 7 plus a plus 1 to the power of 7. So my goal is that again I will do this process so that this power 7 reaches to power 4 so that I can combine the coefficients. So that's why I will not explain that much. Let me explain the next step as well. I copy and paste the first term. For the other one, let me write it here. So I will write it as a plus 1 times a plus 1 to the power of 6. Then I multiply a in. It becomes a plus 1 to the power of 6 plus a plus 1 to the power of 6. So the next one, instead of this, I would write like that. So this becomes a times a plus 1 to the power of 6, and then I have a plus 1 to the power of 6. Again, I copy and paste the first two ones, and then I break this one again. Instead of this, I would write a plus 1 to the times a plus 1 to the power of 5, and I will do the same thing. Okay, so this becomes a times a plus 1 to the power of 5 plus a plus 1 to the power of 5, and one more step I will do. It becomes a times a plus 1 to the power of 7, a times a plus 1 to the power of 6, a times a plus 1 to the power of 5. The next one, what do I write? I will write a plus 1 times a plus 1 to the 4, but I will not continue. So what I actually hopefully could convince you is that a plus 1 to the 8th can be written in this form. Okay, now I will take it with me and put it here. So this becomes a times a plus 1 to the power of 7 plus a times a plus 1 to the power of 6 plus a times a plus 1 to the power of 5 plus a plus 1 to the times a plus 1 to the power of 4. This is what I have written for this one, and then I copy and paste the rest. So it becomes minus 2a plus 1 to the power of 4 plus 1. And that is now my goal. My goal is to combine these two together. So I factor a plus 1 to the 4th out from the right hand side. From the first one, a plus 1 is left. Yes, a plus 1 is left. And from the second one, minus 2 is left. But what can I write this one? I can write that this is a minus 1. Okay, so now what I will do, I will write it like this. So it is a, so let us copy and paste the first few terms. And now a minus 1, a plus 1 to the power of 4. Then I bring the rest of the powers that I don't have with coefficient 0. Yes, as I explained before, and then 1. And now look, what do I have? I have the 7th power, 6th power, and 5th power up to 1st power here, and these are my digits. So these are my digits. And then you see that everything is written in terms of a plus 1. So I don't know, instead of 1, a plus 1, why I wrote 1 plus a, but that's the same thing. Yeah, because my iPad's battery is going to be finished now. Okay, so what I will do, I will write this and then we end the problem. So it becomes a, but a minus 1 as one digit. And then I have 0, 0, 0, 1, and then this is base a plus 1. Okay, so this is the calculation, but remember this, might be it is a good idea that we can check our answers using some specific examples on GeoGebra as well. Okay, now let us check that we have done this formula correctly. So I go to GeoGebra, but I will go to cast view because we will need cast view here. So I don't need the other view, so let us get rid of them. Okay, so for example, I don't know which one you want to prefer. So for example, this is the number that we have here. And then my goal is to have this, checking this formula. So for example, let us, for example, take a to be 15 so that this is indeed base 16. Okay, but if I am working in base 16 and I am taking a to be 15, it means that a is capital F in base 16. So let me write the number and go from base 16 to base 10. To do that, I go to GeoGebra and type this one, And now as you see in GeoGebra, the number that you want, you have to write it as a text. So what I will do, I will choose this one. Text means that I have to put a quotation mark, and then I would write F, 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 because I have chosen A to be F or 15. And then I want to go to, this is the base 16, and I press enter. This is the number F, F, F in base 16. And now what I will do, I click on it and square it to see what will be the number. When I square it, it becomes this number. Now I want to go back to base 16. If we have done the calculation correctly, what you expect to get is that A is F. Okay, so I want to go back to base 16, so you should expect to get F, 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 and before F is E, 0, 0, 0, and then 1, base 16. So that is the prediction. So you should get F, you should get F and F and F, yes, and you should get E, and you should get 0, 0, 0, of course, and 1. Okay, so it's not, I don't know what's doing, but you should hopefully remember. So let us go back here, and then I will write 2 base, and then I click this one and I click on this number. It will copy it here, and then I would write base 16 because I want to go from base 10 to base 16 and press enter, and that is exactly what we did. So it is F, 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 E, 3 zeros and 1. Of course, I'm not saying that bringing one example is the proof, but that's a confirmation that we are on the right track, because first we found the formula, and then we are checking the formula that we found in a special case, and at least it worked according to our expectation. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.